straight into part 2. You previously saw, and hopefully you've written down, all the current values, all the voltage drops and resistive calculations that we had when we solved this bridge as a simple series parallel. Well, I'm going to put a load in here, which is just going to be a resistor from points A to B as we work through Thevenin, calculating Thevenin voltage and Thevenin equivalent resistance. Okay, one thing to keep in mind, we're still working with the example we had last time. This is a balanced Wheatstone bridge, meaning that, of course, we have 8 volts drop here, 8 volts drop here, 4 here, 4 here. So, the difference of voltage potential between points A and B, 0. Because here you will see 8 volts, here you will see 8 volts. What's the difference? 0. So, working with Thevenin. Alright, 4 steps, and these were kind of up here on part 1. Don't know if you got them written down yet, but if not, write them down. First step is to remove the load. Alright, so removing the load consists of removing whatever is between points A and B. Could be a resistor, could be a straight piece of wire per the schematic. Whatever it is, remove it and leave it open. Alright, once you remove the load, calculate voltage, or VTH, across the open. So we've introduced an open to the circuit, and now to get Thevenin voltage, we need to see what the potential is between points A and B. Now, in a balanced Wheatstone bridge, and we've been kind of talking about this, emphasizing this before, there's no difference in potential. So, if we're dropping 8 volts here and 8 volts here, then VTH is going to equal 0. So I'm going to write that up over here. VTH for this particular circuit is 0 volts of potential. Alright, step 3, short VS. Well, actually, let me recap to step 2. It's 0 volts of potential, or Thevenin voltage equals 0, because we have the same voltage drops here. I just want to reiterate, if this resistor was of a different value, and say you had 6 volts here, 8 volts here, the Thevenin voltage, of course, then would be 2, the difference between points A and B. Just want to emphasize that when you're working with an unbalanced Wheatstone bridge. So, again, back. Step 3, short VS. Now again, we're going to put in a virtual short. This does not affect the circuit in any way. We're not really pulling out the voltage supply and putting a jumper wire in. It would be if you wanted to measure it, but calculate it. We just want to put in an imaginary short. If you want to erase the source and put a short there to help you picture it better, that works too. Okay, we short VS. Step 3, right there. And then we calculate RTH. Okay. Now on a Wheatstone, I think it is a little helpful to redraw this so that you can get a better and more accurate picture of how to actually calculate RTH, because it has to be done from the perspective of AB. We're used to seeing, or we're used to calculating resistance as the voltage supply sees it. But now when you work with Thevenin, you have to calculate it from the perspective of A and B. So I'm going to give you another tool to do that. I'm hoping that this will benefit you guys. But one thing I'm going to have you do is label your resistors. I like to just label them by alphabet. So starting with R1, I'm just going to call that A. I'm going to call this B. R2, C, D. And I'm just going to work my way around. It can be any order. Just don't change them up after you decide. R4, I'm going to give E and F, and R3, I'm going to give G and H. Alright, the reason I've done this is so that I can double check my work when I redraw the circuit. Alright, so I'm going to start at point A, and it's going to get a little crowded here up on the board, so please bear with me. I'm going to try to redraw this circuit down here in this area. So, I'm going to start at A. It's my starting point. Go to A. Let's get to going. Alright. A is going to hit points B and C of R1 and R2. So we know it's going to hit R1 and R2, so I'm going to put these resistors next to each other. I don't know what the relationship between them is yet, but I'm just going to draw them like this so that I can connect point A to R1 and R2 and make it look somewhat neat. Alright, so we know it's going to hit B and C. So we're going to call this B. That means that this is R1. We're going to call this C, which means that this is going to be R2. Again, when we make the translation to our new design, don't transpose letters. Make sure that you keep everything straight so that you can do it accurately. Alright, well if this is R1, that's B, that's got to be A. So I'll put A on that side. If that's C, then the other side's got to be D, because that's still R2. And so I'm going to label them R1, R2. Okay, A and D look like they're shorted together. Because of this imaginary short that we have through VS, A and D are going to actually be connected together. So I'm going to close that gap right here. A and D are shorted together. Okay? Now we could continue on, but I'm going to go ahead and I'm going to start at B. I'm going to see what's happening on the B end. So I'm going to go to point B and I'm going to come in. Because there's some sort of consistency between the two. They look like they're mirror images of each other. So I'm just going to jump to B and expect to see something similar to this. Okay, so B comes in. It hits G, it hits F. So we know it's going to hit two resistors, R3 and R4. I'm going to draw these here. I'm not going to be concerned about the relationship yet. I'm just going to draw the points. Alright, we call this F. That means that this is R4, and if we call this G, that means that this is R3. So F, if we've got F there, E is on the other side. So I'm going to draw E on the other side. And for G, we've got H. So I'm going to put H on the other side of that one, and I'm going to label my resistors accordingly. If this is GH, this is R3. If this is FE or EF, that's R4. So R1, R2, R4, and R3. Now again, same thing happens here. E and H. Not only are they directly shorted to A and D, but they're also shorted to each other. So first thing I'm going to do is I'll go ahead and I'll put that short in to short them together. But remember, E and H are also shorted to A and D. So I'm going to make this connection like this. Alright, now this is the Thevenin equivalent to calculate the resistance from the perspective of AB. It doesn't have to be drawn this way. However, if you do redraw it, you have to appreciate the relationship between R1, R2, R3, and R4. You can't change it. So, based off of this, I see R1 and R2 are in parallel with each other. R4 and R3 are in parallel with each other, and this resistance is in series with this equivalent resistance. So again, I said there's no straight one formula for RTH. We've got to create it based off of the relationships. So for this, RTH is going to equal R1 in parallel with R2 plus R3 in parallel with R4. And again, forgive me, I don't have a lot of space to work with, but this is the formula for that. So if I solve this, I'll get RTH.